All right, now there is another way to do this problem other than what we did, okay? We did one method of doing this problem, and there's another one, okay? The first method that we did was to find the probability of having x bar greater than 1150. This is what we did. We said, in order to find this, I need a z-score, which would be 1150 minus 11 over 250 divided by square root of 45. And we found that number, which was 1.34. And we said, okay, here it is, 1.34. This area comes out to be 0.0901. Okay? So then we said, this is not less than 5%. So we are not surprised. This is what we did. There's another way to do this problem. The other way to do this problem is to think, okay, if I'm talking about something like this, which has, I'm talking about a sample mean, and where is it in here? I know that in the middle here is 11. That's the mean of my x bar. And then I say, according to the empirical rule, what would I expect to happen here? And I would say from the empirical rule, I'm going to take the mean plus or minus 2 standard deviations. So then I actually figure out what this standard deviation is. The standard deviation of those things is approximately 0.373. So I would take 11 minus 2 times 0.373, and I would take 11 plus 2 times 373, and I would get two numbers then. This would be like 11.746, and then this would be 10.254. Crystal, is this close to what you got?
Yeah.
Okay. So then I would say, this in between here, this is what to expect. So then I say, what about 11.5? Yes, it is expected. So I'm not surprised. Either one of those methods will give you the same answer. Okay, I am not surprised if I get an 1150. Two ways to figure it. The first one would be to say, okay, what are the chances? The chance is it's a 9% chance of having it happen. Okay, that's fine. Another way is to say, this is bell-shaped. I can use the empirical rule. That tells me what to expect. 1150 is in that situation. So therefore, I'm not surprised by it. Now, these are not exactly the same, okay? Because remember the empirical rule, it's 95% within that interval. That actually means it's 2.5% on either side. So it's a little bit different, but we're not going to worry about that right now. And this is not the question I'm going to ask you on the test. On the test, I'm going to ask you the probability question. Okay. Yes, Casey.
Where did you get the 0.373?
Oh, that is 2.5 divided by the square root of 45.
Okay.
So that's the standard deviation.
Okay. Thank you.
Sure. Good question. All right. So this is something that I think is really good, that we would have two different ways to think about this problem. But don't worry about it, okay? If you feel more comfortable or less comfortable with one way or the other. I want to focus your attention, though, on this one where you actually find the probability, because that's the way that the question is going to be phrased. Okay. All right. So if I take a look at the practice test, which is out there on Blackboard, then what I see is there's a bunch of these area calculations. And then there's some where we have actually data transformations here. And we've done some of this, but we have not done some of it. There's some of it missing here, okay? So what I want to do is just take a little bit of time and work on this, but I don't think we're going to have to take the entire hour, okay? Because that would be crazy since we've done so many of these kinds of problem already. Hopefully it makes sense to you. If there's some issue that you say, hey, I want to do this some more, practice this, that's great. You can do that. But for my purposes, there's not a whole lot more to go over before we can be done for the day. Okay, so let's pick something here, some other kind of problem. So let's say I want to find this probability. And then let's just drop another one on here. I don't know why, but let's just do two of them. All right, check your neighbor's stuff, see what your neighbor's got. All right, Alex, you got something for me for the first one? 0.6622. Yes, that's correct. So then when we look up these values, hopefully we get 1112 and 7734. And we subtract them. Yeah. Okay. Mariah, how about the next one?
I didn't get this one.
Okay. Alyssa, did you get the second one?
I also have not completed.
Okay. I will give you a few more seconds here, see if you can make that happen. Liz Stanish, you got some for the second one? Okay. Crystal Reed, you got some for the second one?
0.0819.
0.0819, that's correct. And this would be 9901 and 9082. All right, any questions about that process here? Yes.
I'm confused when you like take 1 minus, because I thought when it was more than, you subtracted it from 1.
If it is only more than. If that's all I have, then yes, I would subtract it from 1. But if it's between two numbers like this, then I just look up each number separately and subtract. Okay. And again, to understand why that's true, if I do a more than thing, then I want this part. The table always gives me things to the left. Here, if I want between two things, I want this part, then I have this part to the left and this part also to the left. So I have these two sections, but what I want is the difference between them. Okay. Yeah, I think I'll just leave that the way I'm thinking about it. Okay. So, any other questions about these kinds of problems? All right. So, let's go with,
We don't draw the picture on the test. Are we going to lose points?
no. As long as you can do it right, that's all that I care about currently. But if I can't tell where your numbers come from and you have the wrong numbers, then you don't get any partial credit, right? If you draw a picture and so I can tell where you made the error, then you might get more credit than otherwise. Okay, so let's do water quality of PCBs. No idea. How many PCBs are we supposed to have? I don't know. So maybe I should look that up. How many PCBs do you want, really? I'm not sure. So what's the safe level of PCB? Drinking water would be 0.5 parts per billion. So it's okay if it's 0.5 parts per billion. And so let's say that I do a test of my water, and I find that the mean is equal to 0.4, and the standard deviation is, well, this is 0.40, and the standard deviation is 0.02. And I want, well, no, this won't work very well for us. Let's say it's 47. Okay, I'm going to change this to 47. And so then I'm going to say, what's the probability of having a data value greater than 0.5? And we're going to assume that this is bell-shaped. It's probably not a safe assumption. Wow, I have no idea. Nanograms per milliliter? That doesn't make sense. Anyway. All right, Mara, what do you got for me? Okay. Lena Miller, what do you got for me?
I don't know if this is right, but do you take the z-score times the standard deviation plus the mean?
I do not.
Okay, then pass.
Okay. Sierra, what do you want to do? Whoa. All right, okay. Emily, what do you have for me?
Pass.
All right, getting a lot of passing here. So, yes.
I don't have the answer yet,
All
but
right, what do you got?
0.50 minus 0.47 divided by 0.02.
Okay. Data value minus the mean over standard deviation. And what's that going to give me, Crystal?
1.5.
What is on the left side of this equation? Z. This is the z-score for that data value. And I want it to be greater than that. So when I say what's the probability of having a data value greater than 0.5, that's also the probability of having a z-score greater than 1.5. So it looks like this. I want to know what that probability is. Crystal, you got that?
.0668.
0.0668. Now, the fact that I had a number of people who passed could be attributed to a number of different factors, including the fact that it's kind of late in the afternoon and so on. But if you did not understand how this problem happens and how we get to what we need to get to, then you kind of have to look at that, right? I have the mean, I have the standard deviation of my data set. And then I'm asking the question, what's the probability of having a data value in a certain interval? How do I get that? I find the z-score. I then look up that z-score, find the area, make sure that my picture is good because it's greater than. So then I find that number, 0.0668.
So this equation is the z equals x minus the mean over standard deviation.
It is.
So in the parentheses, then that what we were given, that's the x, the 0.5.
Yes, because it says X. All right, so let's find something else here. Let's say What is the probability of having data value between 0.42 All right, check your neighbor's work, see if it's got good results.
Yeah. It's like, so if I get like, I just want to get all this.
Something going on.
So she should have.
Yeah.
Like what I always tell her.
Yeah.
They're pretty far up, you know.
I would not want to suffer, I'd be like,
I know,
I'll suffer.
So then I would write one sheet.
All right, Abby, what do you got?
I got 15.25%.
Okay, that seems reasonable. Casey, is that what you got?
I didn't do it right.
Oh, okay, all right, that's kind of good to know. So Abby, how would you start this problem?
I found the z-score for both of them.
Okay, so then we find the z-score for both of them. I got a z-score of negative 2.5 and negative 1. Okay. So, Casey, is that what you got? Did you get those z-scores?
Yeah, I did it wrong.
Oh, okay.
I got it now.
All right, okay, that's what we want. Get it now. All right, does anybody have any question about those z-scores? Negative 2.5 and negative 1. Yes. Sure, no problem. So when we say, what's the probability of something happening? I know that I'm going to need z-scores. So then my formula for z-score is x minus mu over sigma. So then that would be 0.42 minus 0.47 divided by 2, or 0.02, which is negative 5. And then this would be 0.45 minus 0.47 divided by 0.02, which would come out to be negative 1. Okay, so those are my two z-scores. So then if I'm looking at what that actually means, I have a negative 2.5 here, and I have a negative 1 right here, and I want to know what's in between. Using my z-scores, which corresponds to 0.42, 0.45. So I'm looking at data values between those two numbers. But in order to get to probability, I have to know z-scores. And I want the area between those two numbers in order to make that happen. So then, once I have those z-scores, then just like we just did, I'm going to look up those numbers on the table and subtract those two numbers in order to get the probability of the in-between. So then that would be 1587 minus 0062. So then when I subtract those, I get 15. All right, so let's ask another question of this data set. And let's say, according to the empirical rule, what data values do I expect to get from this? right, Hunter, you got something for me there? Okay, Yinan, do you have something?
For the fifth rule, right?
Yep.
The 0.43 and 0.51.
Okay, and how would you phrase your answer?
Any value less than 0.43 or more than 0.51 is unusual.
Okay, so then if I say what to expect, it would be any values between those two. Okay. You're correct in what you said. The actual thing that I said up here was, what do you expect to happen? And so it'd be between those two. Okay. Now, if 0.5 is the bad level and anything more than 0.5 is bad, then we would kind of expect that some of our data is actually going to be bad. Okay. So we would say that if this is bell-shaped, and if 0.5 is the level where we're going to be concerned, then more than likely, we're going to have some bad values that are going to be concerned. Okay. However, the next thing we want to do is consider samples. Okay. So I'm going to take a sample . So I'm going to be taking a sample of 60 data values. And I'm asking the question then, what is the probability of sample mean let's just say higher than All right, check with your neighbor, see what's going on with your neighbor right now.
But then you have to. No, do this.
Oh, you don't need to find sample, because he's gonna list the sample.
What am I finding?
But we already have the sample, we can just have like he gave us.
That's the answer.
I was looking at this, what do you know that? It says here.
All right, Kayla, what do you got?
.0001.
0.0001. Pretty decent. How'd you get there though, Kayla?
So you do 0.48 minus 0.47 divided by 0.02 divided by square root of 60, which gives you 0.01. Okay, if we're skipping that, then that gives you 3.87.
3.87, okay. So this number comes out to be 3.87. So then, Kayla, what happens next?
Then you find it on your table,
But actually you don't.
but actually don't, because anything above 3.49, you use 0.9999.
Okay.
And then you do 1 minus that.
Yep.
Which gives you 2, like that.
Okay, at the bottom of the table it says, if there's anything out there, then this is what you do. Okay. Now, as it turns out, if we do this and we don't round it off, then that will make things close to this number. It'll still be close to this number. But if we think about what's happening here, let's say you're in charge of water quality, and you go out there and you're measuring 60 data values, and you get a mean of 0.48. Is 0.48 very much higher than 0.47?
No.
It's not. But since we're doing 60 data values, this standard deviation is actually a very small number. So the mean does not change very much from 0.47. So that means if we're talking about the sample mean, this is a big difference. This is 4 standard deviations away, which is very unusual to happen. So since we're taking 60 data values, that means that our samples are relatively accurate, or should be, and so we would not expect it to be this high. So then that would be a thing where we would say, this is an unusually high amount of this chemical. So then we have to figure out if there's something going wrong, pollution. All right, that's enough for me. So we'll call it good. And I'll see you next time for the test.
Oh, no.